Hi everyone. Okay, so in this session, I'm going to give a lecture on the influence line diagram for the truss structures. So basically, the influence lines diagrams has been used in the previous topic, which is on the beam. So we have seen how the influence line diagram has been used to plot or to draw the bending and shear or directions diagram for the beam. Okay, right here we will also use the influence line diagram to draw the force diagram, okay, due to the applied load, due to the movement load in the truss structures. Okay, so without further ado, let's we discuss in detail. Okay, so based on this example 6, I'm going to draw the influence line diagram for the member in one of the member in the truss structure, which is referred to member BG. Okay, so the movement load will give the different value of force, internal force in the member BG. So the concepts remain the same. So to draw the influence line diagram for the internal force for the member BG, you need to apply the 1 unit load. Okay, so by assuming that the 1 unit load is moved from A to E, so in other around we can assume the 1 unit can from the E to A, but in these examples we take that the 1 unit load is moved from the A to E. Okay, so for the first step, basically you need to determine the reaction force at the support A and at the support E of the truss structures. So what you can see in this slide, you can see that they have 4 numbers of diagram. Okay, so which is you need to place a 1 unit load at every joint, where you can see that at the first diagram, the 1 unit load is placed at the joint A. So based on this diagram, you need to determine the value of reaction at support A and E, which is referred to VA and VE. So and second diagram, you can see that the 1 unit load has been placed at the joint B. So and you will get another set of reactions at support based on these conditions of load. And third diagram, you can see that the 1 unit load has been moved to joint C, and you need to get another set of support reactions. And the fourth diagram, the 1 unit load is placed at the joint D, and you will get another fourth set of reaction at support. So basically, this particular 1 unit load need to be placed at the joint E. Okay, but it's not shown here. So you will get a 5 set of reaction value at support. Okay, so they have another shortcut way to get the reaction at support, where you can use the equation. So how to use the equation? So this is the equation that I'm talking about. So the equation at support A, which is equal to VA equal to 24 minus x divided by 24. So how to get this particular equation? So actually you can use this you can place this 1 unit load, okay, on the truss structures. Okay, so and you can put the distance between this 1 unit load towards point A. So which is we refer the point A is our starting point of 1 unit load as x. Okay, so by taking moment at the point A, so you can see that we have 1 multiplied by the x, and VE multiplied by the 24. Okay, so you will get the equation of VA. You will get the equation of VE, and by considering the summation of force in the vertical equal to 0, so you will get the VA. So this is what I have simplified in this slide. So you can justify by yourself how to get this particular VA equation based on this particular free body diagram. Okay, so actually you can simply to get any value of VA, and that means that the VA in this diagram can based on different position of 1 unit load from joint to joint. Okay, so I can show how this can be used in Excel right now. Okay, so this is the equation that I have formulated in the slide. Okay, so I'm placed this equation in Excel. So you can see that this join A, join B, join C, join D, and join E. So where we have put the 1 unit load at all this join. Okay, so this is a x distance where at at A is x is equal to 0. So every join, the distance, the interval distance is constant, which is equal to 6 meter. So you can see that the corresponding value of reaction at support, which is VA, is equal to 1 when I place 1 unit load at joint A. So and when the 1 unit load is placed at the joint B, so the value of VA is equal to 0.75, and the other values, you can see that when I put it, the difference, the value of 1 unit load at different joints. Okay, so basically this equation has been, this value of reactions of VA has been determined based on this equation. Okay, so actually in the test or in the examination, you can simply to calculate all these value of reaction by formulate this particular equation in your calculator. Okay. Okay, so okay, this is our first step. Okay, you need to find out the reaction at support A by placing the 1 unit load at different joint until joint E. Okay, so and what you can see here is our objective is to find out the value of internal forces for member BG. So our objective is to draw the influence line diagram for the internal forces for member BG. Okay, so and the method of section will come in order to get the internal forces of BG. So we don't use the method of joints because our intention is to get the internal forces of member BG. Okay, not the entire internal forces of the structure system. Okay, so due to that, we use the method of sections in this problem. Okay, so you can see that in the diagram we cut or we pass through a line in this way, what you can see in the slide. So one of the member that has been passed through by these lines is member BG. So our intentions, our objective for this particular problem. Okay, so the next step, what you can see here in the step 2, okay, so in the influence line diagram, so the principle is you need to choose the one of the diagram. So in this solution, you can see that the left hand side of cut section has been chosen to analyze the internal forces of member BG. Okay, so you can see that the different figure here, figure 1, figure 2 up to figure 4. So in the figure 1, you can see that the 1 unit load is placed at joint A. So where the corresponding value of a VA is equal to 1 kilonewtons. So you can see that in figure 2, the 1 unit load has been moved to joint B and the corresponding value of reactions at VA is equal to 0.75, where we have determined all this value of a VA for different value of for different position of 1 unit load based on the step 1. Okay, so I has explained in detail how to get the reaction at support by using the formula. So it's up to you whether you want to use this way by draw all the diagram, or you can simplify this by using the equation that I have explained just now. Okay, so you can see that when you move, okay, at the figure 1 and the figure 2, you can see that the 1 unit load is available. In the figure 3 and the figure 4, you can see that the 1 unit load is no longer available. Only you can see that the difference is the value of VA is become 0.5 and 0.25 based on the step 1 here. Okay, so okay, for every diagram here, you need to determine the value of FBG. Okay, so for instance, here in the figure 1, based on this condition of a 1 unit load and the value of a VA, you can see that by considering the summation of force in verticals equal to 0, so by using the method of sections, okay, so you can see that the FBG is equal to 0. Okay, move to your figure 2, you can see that in this figure the VA is equal to 0.75 and the 1 unit load is placed at the joint B. and you can see that the value of FBG is equal to 0.354, and for the figure 3, the FBG is equal to negative 0.707, where in this case the 1 unit load has been moved to the joint C, which is not it cannot be seen in this diagram. Okay, so at the figure 4, in the figure 4, you can see the FBG is equal to negative 0.354. Okay, so basically we supposed to have another figure, which is a figure 5, where the 1 unit load is placed at the support E. Okay, and this will result in the value of FBG is equal to 0, where this is not shown here. I hope that you can justify by yourself. Okay, so we have the series of a value of FBG based on the different position of 1 unit load. Okay, so and by that you can plot the influence line diagram for the member BG. Okay, so here you can see in the table is the value of internal forces for BG based on different position of 1 unit load. Okay, so this is diagram of influence line diagram for the member BG. Okay, so you can see that this is the tension side. Okay, so this is a compression side of internal forces. So you can see that the when the 1 unit load is moved from A to E, you can see that the internal forces in the member BG is changed in terms of value and also changed in terms of the stress value. It means that the stress signs from positive, from tensions to compression. Okay. Okay, so that is the how to develop the influence line diagram for the truss structure. Okay, so in the next lecture, so we will discuss in detail how we can use this influence line diagram for the truss for the real movement load. I mean that the vehicle load. Okay, so I think that's it for this session. So we will continue to apply this particular influence line diagram for truss in the next session. Okay, thanks for listening.